Welcome back. This time we'll try to add more features to our compare utility and write more tests. From last time, you remember we wrote this function called compare streams, which takes two streams as an input and tells you whether they differ or they're the same, and either they are similar up to a point, and after that one of the stream gets exhausted. We wrote a few tests for that. We tested almost every option available. We also looked at string IO and how to use that as a stream as an input to this function. This time we'll look at more options to the compare utility and try to implement those. If I type in compare --help, it gives me all the options that compare supports. Some of the options that we need to support is ignore initial, which will ignore the first X number of bytes from the inputs. And the next most important option is to compare at most limit bytes, where we only compare n number of bytes from both the streams rather than comparing all of it as we currently do. Let's open up a Python shell. Let me source my virtual environment. As you know that we can open a file using a open function. I'm going to open up a file called f1.txt, and then I'm going to read all of its contents, display those, and let me close that. So we just basically open up the file, read all the file, and close the file. This is just to illustrate how seeking in a file works. Let's look at all the available functions and attributes for this file object. So I do a dir on f, and I got a list back with all the attributes and functions. The couple of functions that we are interested in are tail and seek. How file reading works is every file object, for example f here, keeps track of where exactly in the file it is. So it will keep a pointer to where it is right now. If I say f.tell, it tells me that it's at byte number 0. If then I do a read 1, it gives me the first byte back, and then if I do f.tell, it gives me 1. That tells me that it has advanced 1 byte into the file stream. If, however, I do a seek and I say seek to byte number 0, it'll rewind the file object to the very first location. And if I do a tell, that means we're back to the first byte. Let's try reading 1 byte from this file, and it should give me the first byte from the file, and we get a T. So why am I going into seek and tell? That is because when we implement the ignore initial option, which skips the first n number of bytes from the streams, we can use the seek function on the file object or the string IO object to move our stream pointers so that we skip all the bytes at once and not have to do a read up to the n bytes. Why we don't want to read is because read gives you back the contents of the file, and we don't really need those. We simply need to advance the pointer from one position to the other. We don't need that data, and reading from that would bring that data into memory, read the file, and do a bunch of other stuff, and which will make it slower. Rather than that, we simply start at the beginning of the file and seek up to the desired location and start reading from there. Okay, so what I will do is I'll add an option here or an argument to our function, which I'll call ignore bytes. And this is going to be a tuple because we have to know how many bytes to ignore from the first stream and the second stream. If you remember default arguments, you know that if you do not pass any argument to this function, the ignore bytes argument will be set to a tuple 0, 0, which means we do not want to ignore any of the bytes from the streams. And then we can seek that number of bytes from the first file and the second file or the second stream. I call the seek function on both the stream objects f1 and f2, pass them an appropriate number of bytes that need to be ignored. For the first stream, we need to ignore the first entry of the ignore bytes tuple, And for the second stream, we need to ignore the second entry of the tuple. If you want, you can deconstruct this tuple, and now our streams should be where we want them to be. And let's try and write a test case for this so that we know that it does work. I go back to comptest.py and I create a new string IO. I'm going to put in a random text here. So for this test, I'm going to call compare stream with these new variables, and then I'm going to ignore 1 byte from the beginning of the first stream and none of the bytes from the second stream, and this should compare as equal. I'm going to exit from the Python shell and run pytest, and our test passed. The string had one extra character and I wanted to skip that, and I only wanted to start comparing from the second byte onwards, and from the second string does not have any extra bytes, so we don't need to skip any of the bytes from that. And I do that by passing in 1, 0 as a tuple to the arguments of the compare streams function, and that gives me a same written code. You can add more tests to make sure that our new functionality works fine. This was pretty easy. We added a new argument and did a seek on both the streams, and we were done. The next option is to limit the number of bytes that need to be compared. To do that, I'm going to have another option which will be limit, and by default limit will be none. So if limit is set to none, then we are not going to limit the number of bytes we compare. However, if limit is an integer, we'll make sure that we only compare up to that number of bytes and not more than that. To make this easier, let's define a new function which I will name in_limit. So if the current byte number is under the limit, it's okay. If not, this function will return false. If limit is none, we return a true, because if limit is none, we don't care what the byte number is, we keep on moving forward. If the byte number is less than limit, we also return a true. So byte number is the current byte number inside the file. So if the current byte number is less than limit, then we return a true. Otherwise, we know that we have overshot the limit or reached the limit, and so we return a false. So this function returns a true if we can keep on reading and comparing characters from the streams, and it returns false if we cannot. Pretty simple. And rather than having this while true, now I call this function in limit and with the byte number and our limit argument. This byte number will keep on updating at every loop iteration. This limit won't, and as soon as this byte number reaches limit or limit is none, depending on which case it is, our while loop will exit. So let's write a few more test cases for this feature. I'm going to add a couple more string IO objects. So in this test, I want to check whether both the features that we added work correctly. Now I will have two different strings where only a portion of them match, and make sure that the comparison is only done on those. 1, 2, 3, 1, 2, 3, 4, 5, 6 for the first string, and for the second object, string IO object, I have a different string. As you can see, only a small portion of these strings match. And to create this test case, we first skip the 4 bytes from each of the streams and compare the next 4 bytes, which also includes the space character. So the limit would be 4, so we want to only compare the next 4 bytes, and this should be same. And I run a pytest, I get an error, and you can see that we have this assert where compare streams is returning a none while we are trying to compare it against the same 0, 0 tuple. And why is that? So compare streams is returning none. That means none of the if conditions is actually being hit. And if you think about it, in this case, we compare only 4 bytes, and as soon as that byte number reaches the limit, this while loop exits, and there's no such condition to handle it. So the next check we have to have here is when byte number is equal to the limit or the bytes are empty. Because as soon as byte number hits limit, we know that all of the characters matched in both the streams, and those are the same stream. Let's try this, and it passes. Everything is now in place, and we just need to provide a interface for the user to use our program through a command line interface. Let's go ahead and finish that up. If someone is using this script from the command line, I'll make that check here. If name equals main, recall that that only happens when you're actually using that module from the command line. For example, Python cmp.py, and that's when the name would be main. Otherwise, if you import this script in some other script, it will be cmp.py or something else. The first check is to make sure that we have at least the right number of arguments. I'm gonna assume we get at least 2 arguments. So length of sys.argv, and I've already imported sys in our module. So the number of arguments in the sys script should be at least greater than 2, because sys.argv also contains the name of the script, and we need 2 additional arguments for the name of the files. So file A would be sys.argv1, file B would be sys.argv2, and now we have to open these files. So to open these files, we can use the open function with a construct called with. With takes care of closing the files for you once you're done with them, and the syntax is really easy. To open file A, you just provide its path, and then it always opens it by default in the read mode, and you say as, let's say, f1. You can also open multiple files in the same with construct, separate them by comma. I'll do that, and as f2, and now we have to call compare streams with f1 and f2. The only thing that remains now is to check if we have an -i or -n arguments passed by the user. So let's make that check here. I'll say ignore bytes equals 0, 0. By default, we will never ignore any bytes in any of the files. The user has provided an argument in sys.argv. Then I'm going to get the index of that argument, index of I. Let's say sys.argv dot index of -i. -i should also contain the number of bytes to be skipped, so that should be the next argument. So I'm gonna assume that the user was careful to give us the right argument with -i. Args for I equals sys.argv index I plus 1. We have to get the number of bytes to skip from args I. So there are 2 different ways args I can be specified. First is if you want to skip the exact number of bytes from both the files, and the second is you want to skip different number of bytes from different files. So let's make that check. If our args I has a colon, so we'll assume that the user wants to skip different number of bytes. Bytes skipped equals args I dot split, and then we split that with a colon, and bytes skipped is 2 different sets of bytes that need to be skipped, and our ignored bytes would be bytes skipped. So we also have to convert them into an integer. So this function integer takes a string and automatically finds what number it has. It parses the input, and bytes skipped 0 and 1 contains the bytes that need to be skipped from both files. Otherwise, we have bytes skipped equals to int argci and ignore bytes equals bytes skipped comma bytes skipped. We have to skip the same number of bytes. So that's good for our -i option. Now let's get to -n. We do the same. If -n in sys.argv, then the user must have specified how many number of bytes we should compare. So I'll just copy paste. It's almost the same code. Let's rename the variables. Index n has the index of -n. Argn is the index of number of bytes we need to compare. And limit by default is none, as we do not want to limit the number of bytes that need to be compared. This time we'll just say argn. So this is now the limit of how many bytes need to be compared. And we pass that to our function, and hopefully we are done. Let's also take care of the case when the length is not correct. We'll say else print the message saying that they need some extra options to the command line, and that'll make use of the f-string feature of Python. We have looked at this earlier. So sys.argv 0, and I'll say file A, file B at least, and then you could have equals skip 1, skip 2, and -n. So when you put something in brackets, it's usually an option and not something that's required all the time. And I'll just be more verbose here. Okay, so let's do a test run. If we don't provide any arguments, it does that. And I have two different files, f1.txt, f2.txt. Okay, so it doesn't print any output, and that's because we never use the return value from compare streams. So let's go ahead and do that. Byte number and line number. If the code is same, we don't do anything, so we'll just sys.exit with 0, and sys.exit exits the program with that particular return code. For example, if you say sys.exit 0, it'll exit the program without doing anything. Else, if command equals diff, will print, let's just say, file A and file B differ at byte number on line number. Okay. Else, if the code is EOF1, I'm going to say file A exhausted after byte number on line 1, and let's also take care of the case when there's a EOF2, and we'll say file B exhausted after byte number. So these messages are a little different from what the compare utility prints. You can go ahead and change to whatever you want to print. It does not give us, oh, these are not f strings. So let's make them an f string. Okay, so that's good. And let's try f1 and f3. Let's try f1 and f1. And with that, we're basically done. To recap, we wrote a function which does bulk of the work of this utility, and then we wrote a bunch of test cases to make sure that it does behave correctly in all the cases we want. And we wrote test cases to make sure it behaves correctly in all the cases. And after that, it was basically invoking that function with the correct arguments. We did some command line parsing, and go ahead, modify this program, see if it does not give you the right answer for some inputs, and then add to the test cases, fix this. For now, I'll just leave it there, and I'll see you next time with a different utility.